This is an introductory video to Chapter 8 where we will be discussing confidence intervals. Please consider two definitions you learned at the beginning of this course. We have a numerical characteristic of a population, which is a parameter, and we also have a numerical characteristic of a sample, which is called a statistic. A new term you're going to use in this section is called a point estimate. And a point estimate is a single number computed from a sample, and that number is used to estimate a population parameter. A sample mean, for example, is a point estimate for the population mean. And a sample standard deviation, S, is a point estimate, but for the population standard deviation. After calculating point estimates, we are going to construct intervals. A confidence interval is another type of estimate that provides an interval of numbers rather than just one number. In other words, a confidence interval, it's very similar from a range of values. Go ahead and pause the video and read example 1. In letter A, you're asked to define the random variable x, and our random variable is the number of songs one downloads from iTunes in a month. We're also asked to find the mean. And that's the mean number of songs downloaded each month by a random sample of 100 customers. In letter B, we're asked to identify the mean, the population standard deviation, and n. We're given that our mean is 2, our population standard deviation is 1, and our sample size is 100. In letter C, we're asked to use the central limit theorem to describe the distribution. Can we use the central limit theorem here? Our sample size is 100, and since that's greater than or equal to 30, we're allowed to use the central limit theorem. So in this case, we are going to have a normal distribution with our mean, with our standard deviation divided by the square root of our sample size. In letter D, we're asked to use the empirical rule to find and interpret the 95th percent confidence interval for the population mean. Please, let's remember what percentage falls within one standard deviation of the mean, 2 standard deviations of the mean. And if you'll recall, we will have 68% of our information, our data, falling within 1 standard deviation of the mean. And you might recall from Chapter 6 that when we're 2 standard deviations away from the mean, what percentage falls within that area? And that is 95% of our data falls within 2 standard deviations of the mean. Now, let's tackle example D. We're asked to find a confidence interval to interpret the 95th percentile for the population mean of songs downloaded per month. Here's what we're going to do. We're going to start with an interval, and the lower bound, our lower estimate, is going to be our mean minus 2 standard deviations here, where the upper interval is going to be our mean plus 2 standard deviations. And to get a visual representation of it, our mean falls in the very center. 2 standard deviations to the left and 2 standard deviations to the right would be this shaded area within here. I'm going to go ahead and plug in those values with my mean and my standard deviation for my lower bound and for my upper bound. I'll compute those, and we'll end up with a confidence interval of a lower bound of 1.8 and an upper bound of 2.2. But what does this mean? What this means is we can be 95% confident that our true mean for the number of songs downloaded a month from iTunes is somewhere between 1.8 and 2.2. We don't know that for sure, but we can be 95% confident that the true population mean falls somewhere in this interval. In Chapter 8, we'll be finding a lot of confidence intervals. And what you will be doing is finding the point estimate minus the margin of error and the point estimate plus the margin of error. The margin of error is also called our error bound. In the last example, when we did 2 times the standard deviation and we subtracted that from our mean, or we added 2 times the standard deviation, in this case 2 times the standard deviation happened to be our margin of error, or our error bound. And we'll talk more about that in the future videos. That's the end of the introduction. I hope you found that helpful.